Good morning, and today we have the second lesson in the higher straight line course, and we are going to be looking at collinearity. Now, if you've already done the vectors topic, then you will have seen collinearity. So this is a different method for collinearity that we're going to be looking at. And this one is the more preferred method when we are dealing with two-dimensional coordinates. Okay, so here we have a line with 3 points marked on it, P, Q and R. The two lines, P to Q and Q to R, are parallel and form a straight line. Points that lie on the same straight line are said to be collinear. So if they have a point in common, then that makes them collinear, all along the same straight line. That's what collinear means. So let's look at a question here, which is a higher question. Prove that the points P, Q and R are collinear. Again, if you have seen the vectors topic already, then you have a method for doing this. So here's an alternative method. Okay, so we have P and Q. What we're going to do with those 2 points is we're going to find the gradient from P to Q. So the gradient from P to Q, y2 minus y1 over x2 minus x1. Now when I'm doing the gradient at this stage, I don't have to label the top of these with y1s and x1s and so on. You can if you still need that little bit of support. But I just start at the most right hand side number and I take away my 2 right hand side numbers. So minus 2, minus 3. Then I go to my inside numbers, minus 1, minus 2. Okay. So that gives us minus 5 over minus 3. Do not leave it like that. You have to know that if you have a negative divided by a negative, it is an overall positive. So you have to leave your answer as a positive 5 over 3. Okay. Now we've looked at the gradient from P to Q. Let's see what the gradient is from Q to R. Do exactly the same thing. So we're going to work out the gradient here. We have minus 12. Watch out for the double negative. Minus 12 minus minus 2. And minus 7 minus minus 1. Watch out for your double negatives there. And remember, minus 12 minus minus 2 is minus 12 plus 2. So from minus 12 we're going up 2 to minus 10. And from minus 7 we're going up 1 to minus 6. Simplify. The numbers have to be simplified here as well. And that simplifies to 5 over 3. So we have the same gradient from P to Q and from Q to R. And then we have to write the following statement now. It's a statement that people often lose marks on because they don't write all of the important parts. So I can't stress enough to you how important it is to write the statement out in the way that I am going to show you. So we've just worked out that our gradients are the same. So as the gradient for PQ and the gradient for QR are equal. That means the lines are parallel. We must write the word parallel in this statement. And it's the fact that Q is common to both of these lines, PQ and QR, that we can then say the points PQ and R are collinear. So we have to say that the gradients are equal, which means the lines are parallel. Then we have to say that Q is common to both of the lines, PQ and QR, and that's what means P, Q and R are collinear. If you miss out the word parallel, miss out the fact that we've got Q is common to both, you will not get the mark for this. A common mistake that people make is just by saying the gradients are equal, the points are collinear. They miss all of the bit in the middle. So you've got to be very, very careful to put that in to get the full mark for it. Okay, so we're now on to exercise 1B. And I have a selection of questions here for you. And as always, if you have any questions, just message your teachers for help and send in photos of your corrected work so we can give you advice and feedback. Okay, and good luck and take care.